finish off with, let's just do a little recap of our trends. So here are some shadows of the periodic table that give you, a little bit on our atomic size. This one, what these do is they're going to show you the direction in which things increase. And so atomic size increases as you go this way, increases as you go down. Electron affinity increases and increases. Now notice all the dashed lines in that electron affinity, okay? Because remember, electron affinity is kind of crazy and it's not as well defined. All right, so there's a recap of our trends. Now, when I look in my particular groups, all right, again, my 1A, 1 valence electron, 2 all right, and so I see similar behavior. Like if you look at magnesium and calcium over there in group 2A, the little turnings look very similar. When I look at my 1A, those are all very reactive with water. Very, very reactive with water. We have to store them in mineral oil because they'll react with the water vapor that's in the air around us. And so we see these similar behaviors because of the number of valence electrons there. All right. When I look at my halogens, okay, here's where we see really well that metallic character trend. They're all nonmetals, but chlorine is a gas, bromine's a liquid, and then when I go to iodine, now I have this solid that's nice and shiny. It has luster to it like we expect out of our metals. Okay, these are group 7A. So we have 7 valence electrons. All of these guys exist naturally as diatomics, F2, Cl2, Br2, I2. All right. Very similar behavior. They all have, that want to put in one more valence electron for their bonding. Okay. You can see with my halogens there. So again, the electron configurations, they all have 7 valence electrons. They have an NS2, NP5, all of them. Okay, it's that same. Okay, for whatever energy level they're in. Okay, we see things with that electron affinity. It goes 328, 349, 325, 295. So again, that bouncing around a little bit there because the electron affinity is not quite as well defined. But the atomic radius, as I go down, 72 to 99 to 114 to 133. It gets bigger as I go down. Okay, my melting points go up as I go down, which also makes sense because I'm going from gas to a solid, so it should take a lot more energy to melt the solid. Okay, same thing with boiling points, same things with my densities, right? So it all tracks. There's those group 1A metals, very reactive in water, potassium being of the lithium, sodium, potassium being the most reactive. So out of those 3, the valence electron is the furthest out. It comes off the easiest, has the lowest ionization energy between lithium, sodium, and potassium. And so it pops off relatively easily, and so we get an even more violent reaction. When I look at my noble gases, again, they all have that full valence shell. They don't like to react at all. But as I go down, they get bigger. As I go down, my ionization energy decreases. Okay, and so we see, again, these trends within our groups. Those valence electrons, they give us a lot of information about what we can expect from our various different elements.